So now we're ready to look at transformations. And to help us do this, we're going to start off with a basic graph and pick 5 points of the basic graph to follow as we apply various transformations to develop a new graph. So consider the following W function whose graph is given below. So this is the picture. It looks like I got an extra dot there. I'm not sure why that's there. So a little typo. But anyway, just ignore that dot up there. And so this is my W function. And it goes through these points here, 0, 2, 2, -2, 3, 0, 4, -2, and 6, 2. And so now we're going to apply various transformations to this W function and then see what happens. So let's first look at vertical and horizontal shifts. So let's go graph g of x equals w of x plus 3. And here what we're doing is we're adding 3 to all the y values. So if I go back to my points up here, I'm going to just take each of my y coordinates on these points and add 3 to them. So that's what I do over here. And that gives me my new points. So the original point was 0, 2. I added 3 to the y coordinates, now 0, 5. 2, -2. Add 3 to the y coordinate, that becomes 2, 1. So on and so forth. So when I plot these points, notice my graph is shifted up 3 units. So it's shifted upward 3 units. So in general, the graph y equals f of x plus k is the graph of f of x shifted k units upward, and the graph of y equals f of x minus k is the graph of f of x shifted k units downward. Now, let's this time put the number inside with x. So now we're going to consider the function h of x equals w of the quantity x plus 4. Now remember what my base points were. Here are my x and y values of my original function. I have to get that x value up to 4. So, in other words, x plus 4 has to be equal to 0 in order for it to pick up on that original w function. Well, if I solve this for x, I'd have to subtract 4 from both sides. So that means on this new function, the point's going to be -4, 2. Likewise here, if I said look at my w function, if I said x plus 4 equal to 2 and solve by subtracting 4 from both sides, I'm going to get x equals -2. So notice, even though I have a plus 4 here, notice it gets shifted in the opposite direction. So with horizontal transformations, it's always shifted in the opposite direction. And again, the way you tell the difference between a vertical and horizontal shift, the vertical number, the number is being added or subtracted outside the function. With a horizontal shift, it's being added, subtracted when inside the function right next to the x. So we want to notice that the graph was shifted horizontally 4 units in the opposite direction. Horizontal shifts will always be in the opposite direction. So the graph of y equals f of quantity x minus h is the graph of f of x shifted h units to the right. And the graph of y equals f of x plus h is the graph of f of x shifted h units to the left. So now let's say I formed our new function. J of x equals w of the quantity x plus 4 plus 3. So my vertical shift is 3. My horizontal shift is going to be -4. In other words, 4 units to the left. So I'm going to shift 4 units to the left and up 3. So I'm just going to apply both of those transformations. So if I take this point here, I shift it 4 to the left, 1, 2, 3, 4, and then I go up 3. 1, 2, 3. Boom, there it is. This point here, I'm going to shift to the left 4, 1, 2, 3, 4, and then up 3. 1, 2, 3. So this graph, each point was shifted 3 units up and 4 units to the left. So let's go to our workbook so we're going to skip here. Find the page. So we're going to go to page 36 of our workbook, and we want to try some of these problems. And so what we want to first do is we want to describe the transformations. So is it being shifted vertically? It's being shifted horizontally, so on and so forth. And then we want to actually go and sketch the graph. So if I look at this one, notice 2 is outside of the square root. So this is going to have a vertical shift of 2 units up. Now compare it to number 2. We're going to graph these in just a minute. Compare this to number 2. Notice where that plus 2 is. That's underneath the square root. So it's right next to the x. So that's how you can tell the difference. So this is going to be a horizontal shift. And remember, it's in the opposite direction. So it's going to be horizontal shift of 2 units left. Now this is why I ask you to make sure you have that parent function memorized before. So if we look at the square root of x, here's the parent function. Looks something like this. And we have these 3 points, or what I sometimes call anchor points. So on this first one, I want to take each of these points and I want to shift them up 2. So looking at that first point, 0, 0, I'm going to shift it up 2. 1, 2. It goes here. My next point is 1, 1. That's here. I'm going to shift it up 2. 1, 2. The third point here is 4, 2. I'm going to shift it up 2. 1, 2. So now I've taken my parent function, the square root of x, and I've shifted it up 2. And I'm going to just draw in the curve. Looks something like that. For problem number 2, doing the same thing. But this time I'm shifting everything 2 units to the left. So I'm going to start with my point 0, 0. And I move to left. 1, 2. Next point is 1, 1. I'm going to shift to the left. 1, 2. Third point is 4, 2. I'm shifting to the left. 2. And then I'm going to sketch in my graph. Now notice when you have a vertical shift, it's not going to change the domain compared to your parent function, but it's going to change the range. My range now would be 2 including 2 to positive infinity. Whereas if I have a horizontal shift, that's going to affect the domain. My original domain here was 0 to infinity including 0. Since it got moved to the left 2 units, it's now my domain of this new function would be bracket -2 to infinity. Let's try some more. So here we got g of x equals x squared minus 2. And so, again, this is outside of the function. So this is going to be a vertical shift of 2 down. So we're going to vertical shift of 2 units down. Now notice this is inside next to the x, so this is going to be a horizontal shift, again in the opposite direction. So this is going to be a horizontal shift of 2 units right. So again, I've got to grab the parent function. And remember, that's our classic U shape. It's called a parabola. And I'm just going to pick a couple of these points to follow. But we know we got to draw on our U shape. Let me go ahead and put a couple more here, just so we can kind of get a better shape here. Okay, so here we're shifting this down by 2 units. So here's 0, 0. I'm shifting down 2 units, so this goes to -2, down to -2. So it'd be 0, -2. And again, if it helps you, when you got a vertical shift, it's like you're shifting down 2 units, you're subtracting 2 from the y-coordinates. So like this point here at -1, comma 1, if I subtract 2 from the 1, that gives me -1, -1. So notice again, it got shifted down 2 units. -2, comma 4, shifted down 2. Again, it's like I'm subtracting 2 from that 4. That gives me this point. And by symmetry, we're going to get the same thing over here. My domain of this function is still all real numbers. However, the range now has changed because we had a vertical shift. My range here would be from -2 to infinity. So let's do a horizontal shift. So now I'm shifting 2 units to the right. So I'm looking at this point 0, 0. I'm shifting to the right 2, so it goes here. 1, comma 1, shifting to the right 2. And again, the way I can think of horizontal shifts, if I'm shifting 2 units right, I'm adding 2 to all the x values of my anchor points. 2, comma 4, move it over 2, and then by symmetry, you're going to get these same points over here. Now notice here the horizontal shift really doesn't affect the domain, because my domain was already all real numbers. If I shift it over by 2, it's still all real numbers. So those would be our graphs. Let's turn the page and let's do a couple more. All right, so we want to describe the transformations and sketch the graph. So on this one, now we've got both of them going on. So we got a horizontal shift going on here and a vertical shift here. So this has been my horizontal shift is 3 units to the right. And my vertical shift is 1 unit up. So again, notice that the vertical shift goes in the same direction, horizontal shift in the opposite directions. So again, kind of going back to my parabola we just did, my first point was 0, 0. I'm going to shift it 3 to the right and 1 up. 1, comma 1, 3 to the right, 1 up. 2, comma 4, I'm going to shift 3 units to the right, 1 up. And do the same thing on the other side. That gives us our parabola. And now let's look at this one. My horizontal shift. Just think about it for a moment. Remember, it's in the opposite direction, so I'm going 1 unit left. And then that would be, my vertical should be 4 units down. Okay, so I'm going, starting at 0, 0. I'm going 1 unit left and 4 down. 1, 1, 1 unit left, 4 down. 4, 2, 1 unit left, 4 units down. So it's just like I'm taking my x coordinate, I'm subtracting 1, and then taking the y coordinate, subtracting 4 to get these points. And then we sketch in our graph.